So what we're going to do is we're going to solve an equation. We've done this ammonia equation. So basically when we get done, here's our equilibrium expressions of concentrations we have expressed in terms of X. So when we set that up, K equals the amount of nitrogen, the pressure basically, not amount. We're going to do in terms of partial pressure, the amount of hydrogen expressed in X, and it's cubed over the amount of ammonia that remains, the pressure of the ammonia that remains, and that's squared. So basically we can look at this expression and say, oh, I've got a cubic part here and a squared part, so we know this is going to be bigger than a quadratic. So we're going to just go right to the solver on this. So I want to set it up first with the TI80, and so I'm going to just show you where to do that from. So I'm going to exit out here, and this is how you would normally have it if we were doing calculations with this TI80. To access the solver, we're going to go to the math, and then you could either roll down or up, but basically it's below the 7 down here. So if you keep arrowing down, you'll get to the solver. There it was. I just passed it. I select it, and the very first thing that comes up is it's looking for an equation. So I'm going to go up and get the equation. I'm going to just clear this all out so you can kind of see how we program this. So I'm looking for the equation first, and again, for the solver, it will only solve if you solve for 0. So what we need to do with this expression is get it where it equals 0, and the way we could do that very simply is subtract 50 from both sides. And so now it would look like this equation minus 50 equals 0. What root of x would actually make this true? So here we go. And the equation is, I'm going to start off with, now when I enter x here, I can't use the alpha x. I got to use the x t theta on the TI80. That's the x that's in programming. It looks like x times quantity 3x and that expression is cubed. Oh, I'm gonna back up a little bit because this whole thing has to be in parentheses, right? That's what we see here. The whole thing has to be in parentheses. So x times quantity 3x, and that whole thing is cubed, so I'm going to raise it to the 3rd power. Now I'm going to divide this, and I'm going to be a little careful. I'm going to block this off so everything that's divided is down on the bottom over here. So I'm going to go 5. Actually, I'm going to give myself another little parentheses. 5 minus 2x, and that whole thing has to be squared, and then that whole quantity is on the bottom, and then remember that we have the bigger block, and now the whole thing is minus 50. So hopefully we got this set up correct. Now basically what you can do here is I'm just going to clear this out so it's distracting. That's old answer. Sometimes when you turn these on, you'll have an old answer sitting there. But I'll just clear it for now, just so you can kind of not be distracted. I'll just put a 1 in there. Now, the bounds are where I'm going to logically look. So I'm going to start off with a very small amount. That means I'm basically looking, and my first x would be somewhere at 0.001, and then I'm going to start climbing. But I do have a logical upper bound on this, and that is based on the chemistry, that if I start with 5 psi, I can't lose more than 5 psi. So 2 times 2.5 would be 5. So the upper boundary for this would be 2.5. So I've got that. Everything's in place. Got that entered. Now what I want to do is basically tell it to solve, and I have a green key down here that says solve. It's kind of hard to see on here, but so I'm going to hit activate the green key. I'm going to say solve. You'll notice it's thinking on the right, and then boom, it pops out the right answer. So the root for this is 1.581. Now just to show how powerful this is, you could go back up and work with the equation again, and then let's pretend that the K wasn't the K wasn't 5, but it was something real low, like 1e to the minus 3. So now I know that basically I've got, you know, if this had been 1e to the minus 3, just to show you how this works, the only thing that would be different is now I have a different K, and we know if that were true, then I would make a lot less than I made the last time, right? So everything's going to be pretty much the same. The bounds are, I'm going to change that out again. 2.5 is a reasonable upper bound for this. Okay, that's good. Now we're ready to calculate. Alpha solve, it's thinking, and I make a lot less ammonia. It'd be 0.168. So that's how you would do the TI84 programming using the solver. Key point, always set equal to 0. Select some reasonable bounds.